Have you ever wondered what it really takes to become a data scientist? I mean, beyond all the buzzwords, what's the actual blueprint? Well, today, that's exactly what we're going to do. We're going to tear down a real-world master's in data science syllabus and uncover the step-by-step path from day one to full-blown expert. All right, let's get into it. You know, the course material literally asks this on the very first page, and it's just the perfect question. Because this isn't just about learning some new skills. It's about a total transformation. So really, are you ready? Let's take a look at what that journey actually involves. So here it is, the full 2-year course grid. And yeah, at first glance, it can look a little overwhelming, right? Just a big list of subjects from Python all the way to deep learning. But we're not just going to read a list today. Oh no, we're going to deconstruct this thing to understand the story it tells, the story of the skills a modern data expert really needs.
And it is a deep story. We're talking about an 80-credit program here. This is no weekend boot camp, folks. This is a comprehensive, deep dive designed to forge a professional from the ground up.
Okay, so here's our game plan. First, we're going to start with the why, the data scientist's core mission. Then we'll get our hands dirty and forge that foundational toolkit. From there, we dive into the really exciting part, mastering machine learning. But hey, a model is useless if it just sits on a laptop, so next, we'll talk about engineering the data future. And finally, we'll see how it all comes together in the major project payoff. Let's start with the big picture. I mean, before you write a single line of code, you have to know what the goal is. What is a data scientist actually trying to do? And it's laid out right there in the course description. You're basically part strategist, part detective, and part builder. Your mission, should you choose to accept it, is to take messy, raw, chaotic information, find the hidden patterns nobody else sees, and then use those insights to build tools, data models that solve tangible, real-world problems. So how do you even start on a mission like that? Well, you start by building a rock-solid foundation. These are the non-negotiable, you gotta have them skills that everything else, and I mean everything else, is built on. First up, your weapon of choice, Python. It is the language of data science for a very good reason. Mastering Python isn't just about writing scripts. It's about thinking in algorithms and using these incredible libraries like NumPy and Pandas to grab, shape, and mold data into something you can actually use. It's the bedrock. Now, if Python is your workshop, then SQL, well, SQL is the key to the massive warehouse where all your raw materials are stored. It's how you talk to databases. And believe me, the syllabus goes deep here, because this is a fundamental law in data. If you can't get the data out, you can't do the science. Simple as that.
And this right here, this is the brains of the whole operation. Your code gets you the data, sure, but statistics is what tells you if that data actually means anything. It's the framework that lets you test your ideas, understand uncertainty, and make sure your conclusions are legit, not just some random fluke. It's what separates real science from just guessing.
Okay, foundation is set. Now we get to the heart of what modern data science is all about. This is where you learn to make the data not just tell you about the past, but actually help you predict the future. And you can see there's a really clear path here. You don't just jump into the deep end. You start with the fundamentals in the first machine learning course, then you level up to more sophisticated models in advanced machine learning, and finally, you tackle the absolute cutting edge with deep learning, building these complex neural networks that are inspired by the human brain itself. So, what are these models actually doing? Well, they basically learn in 2 ways. With supervised learning, think of it like you're a student with an answer key. You're training the model on data that's already been labeled. But with unsupervised learning, you're more like an explorer. You just give the model a bunch of unlabeled data and say, go find the hidden patterns for me. And the toolkit you end up with is just incredibly powerful. The curriculum covers all the workhorse models, like regression and decision trees, but it also goes right to the state-of-the-art. You're learning things like convolutional neural networks, which are amazing at understanding images, and recurrent neural networks, which are brilliant for processing things that come in a sequence, like language. So you did it. You built this brilliant, mind-blowing predictive model. You're done, right? Not even close. Now comes the really hard part, making it actually work out there in the real world. This is where the scientist puts on their engineer's hat. And this is maybe the most crucial takeaway. A model sitting on your laptop is just a cool science experiment, but a model that's serving predictions to millions of users, that's a product. And this part of the curriculum is all about bridging that massive gap.
So you dive into what's basically the modern playbook for deployment. You learn how to use microservices to keep things manageable. You package your apps in containers with Docker so they run anywhere. You automate everything with CI/CD pipelines so there are no human errors. And then you manage the whole shebang at massive scale using Kubernetes. It's how the pros do it.
But what about the data itself, especially when you have tons of it? Well, that's where the heavy machinery comes in. We're talking about tools like Hadoop to store data across huge clusters of computers, Spark to process those giant data sets like Lightning, and Airflow to automate the complex data pipelines that keep your models fed with fresh, up-to-date information.
Okay, so after nearly 2 years of building this incredible set of skills, it is time for the final exam. But this isn't some multiple choice test. No, this is a challenge to prove you can actually do the job.
I mean, that's the ultimate question, isn't it? After all this theory, all these tools, how do you actually show the world that you've mastered this craft?
That's it. The answer is that simple and that profound. You don't just talk about it, you go out and build a real, functioning, end-to-end data product.
And that's what the major project is all about. It's the synthesis of everything. The goals are crystal clear. Build a complete machine learning pipeline, from cleaning the raw data all the way to deploying the model. Create an app that can process data in real time, and automate the entire pipeline so it can run all by itself. This is that moment where it all finally clicks into place. The Python programming, the statistical checks, the advanced machine learning models, and all those cloud engineering skills, they all come together to create one cohesive, impressive piece of work. It is the final proof.
So there you have it, the complete blueprint for a modern data expert. It's a journey from fundamental principles all the way to complex real-world engineering. The path is laid out for you. So the only question left is, what problem are you going to solve first?
Thanks for watching. If you learned something new, don't forget to like the video and subscribe for more awesome content.